Alright, so today we're going to finish ellipse by first looking at how do you make a standard form equation. In order to make a standard form equation, you got to have three things. You got to have the center. Now we talked about in our circles a center. Did you notice that we haven't talked about a center in parabolas? That's because the center is the vertex. Think about it. What's halfway between the focus and directrix? The vertex. So in a parabola, the vertex is the center. But in these problems, there's a real center. And then your vertices are around it, and your focus is in between the vertices and the center. So because of that, we've got to use what they give us to help us to find that center. We also have to use what they give us to find the A and the B that go in the formula. So the format that we're looking for today in order to make our equations looks like this. X parentheses minus h quantity squared plus y minus k quantity squared. And underneath these, we have to decide if a squared goes here or there. Because whichever one has a squared, b squared is going to go on the other one. So it could be a squared, b squared, or it could be b squared first and then a squared. Depends on which way it's longer. But it's always equal to 1. So first, once we decide which one's a, it won't be hard to figure out which one's b. But it's squared when you put it underneath the fractions. So first of all, I look at this problem and I think about it. If I plot negative 8, 0, won't I be here? And if I plot 8, 0, won't I be here? And what's exactly in the middle is the center. So in this case, it happens to be 0, 0. Not all of them are 0, 0. So there's my center. So now I know my formula is x squared plus y squared equals 1 for the tops, because x minus 0, I don't have to show that, right? If I'm plugging in 0, 0 for my center, I don't need to plug that in and show anything. Then my focus are at negative 5 and positive 5. So let's talk about what those vertices in that focus give us otherwise. Well, first of all, the distance from 8 to the center is A, which is 8. And the distance from the focus to the center is C. So it's very important to graph it and visually see where the center is first, and then count from the vertices to the center so you know A, and the co-vertices to the center would be B, but I didn't have co-vertices, did I? And then the distance from the focus to the center is C, so I've got to use that Pythagorean relationship to find B. Because C squared equals A squared minus B squared. That Pythagorean relationship that has plus or minus in the middle of it, that's the opposite of what your problem has. And since ellipse has plus, the Pythagorean relationship has minus. So I plug in what I know is 5 squared equals 8 squared minus B squared, and I solve for B. Alright? So that's going to be 25 equals 64 minus B squared. Now, if you go back and think about elementary school, 5 minus 2 equals 3, right? 5 minus 3 equals 2. Do you see how you could just switch the two things position-wise that you're subtracting it from and the answer? So B squared equals 64 minus 25. Because it doesn't matter which one of those two I subtract from the 64. And that saves a little time on solving, if you know that. Otherwise, you'd have to subtract the 64, divide by negative, and still get that. So now, what is that?
39.
39. So the square root of 39 is B. Interesting thing. Don't really need to know what the square root of 39 is, but that's still what it is. Because when I put it in over here, it's got to be squared, right? So I should have just left it B squared equals 39. But let's go back and talk about A first, because we got to know which one's A. So when I moved from 8 to the center, did I move in an X direction or a Y direction? An X direction, because X's go left and right. So therefore, I have figured out that that 8 squared is 64 goes under here, and that square root of 39 squared just makes 39 go back to what it was before I square rooted it. So why square root it in the first place? Because the numbers under there are always b squared and a squared. And that's all you do for that part. Does that make sense? So that's why when I put it in over here, there's nothing on top but x squared and y squared because we put in the 0.00. Because if I put 0 here, that goes away, right? But I have to figure out which one goes where for A and B. Because it's not always A first. It's which one is the vertex and focus on. An X direction or a Y direction. Alright, let's look at number 2. Number 2 uses some different terminology from what we used when we were labeling things. It says the major axis vertical with length 10 and the minor axis length is 4. The center is at -2, 3. The major axis is vertical, means that it's up and down. The minor axis then would go across. Would everybody agree with that? So therefore it's 10 up and down and 4 across. Now that's not A and B, that's the whole entire picture. The major axis length and the minor axis length is actual length all the way across the picture, up and down and across. But we need to know that the major one is the longer one, because that's really important to know. If it said the major axis was horizontal, then it would be laying down. Does that make sense? So since it's 4 all the way across, that makes these two are both 2, right? And these two are both 5 if it's 10 all the way across. So now I know A is 5 and B is 2 because A has to be bigger. Does that make sense so far? And I didn't actually plot my center because it didn't really have anything to do with the major and minor axis lengths. I just threw a picture up here and described what does those vocabulary words mean in relation to the picture.
So if it was on the graph, the middle would be at negative.
Right, if I put it on the graph, it would be at -2, 3. So now let's fix our formula. So when you make an ellipse formula, you have to pick the center and make it the opposite to put it back in with x, which would be x what? And then the y would be, then you look at which way was longer, x or y, and take your a and square it. So since a is on the longer one is with y, you're right, we're going to put 25 under the y. And then if we square the b part, it goes under the other one, which happens to be 4. So that's why it's important to figure out how long each side is and not how long the whole entire length is, because the whole entire length doesn't have anything to do with A and B. A and B is how far is it from the center to the vertices, or the center to the co-vertices. So you get a lot more information that you can work with quickly when they give you the axis lengths. In our third problem, they've given us some partial information. First, they told us the center. So I'm going to graph it since they gave me a vertex. So over 2, -1 is my center. Then they gave me the vertex is over 2 up a half. How far is that? 1.5? Well, that'll be A. How do I know it's not B? Okay. Not only that, but it's the distance from the center to the vertex always is A. It's co-vertices, it's B. So that's also another clue. Minor axis being 2 goes the other way. So it means it goes one this way and one this way. You're right. If I divide that in half, I get 1 and not 1.5. So that's another good clue. That was a good clue. So now I know that my B is 1 and my A is 1.5. I already had in the center. I could have already had the problem written out. I could have already said this part without even reading anything else into the problem, right? Because I know how to put a center back into two parentheses that are squared. And I know that the standard form of problems are always equal to 1. But the key here is I have to have something underneath these. So therefore, since I'm supposed to have something underneath them, I'm supposed to figure out what A and B are. Now again, A was found by counting from the center to the vertices, which is 1.5, but we still got to square that, and we still got to figure out if it's X or Y. X or Y. Correct. It went up to the vertices. If it goes up and down, it's all about Y. So 1.5 squared is 2.25, because that's just 15 times 15 with moving the decimal over twice. Which is why knowing your perfect squares is important. Because if you know your perfect squares, you could have just said 15 times 15, let me move the decimal over twice. One for each of the 0.5s.
So if the bigger number is under Y, it's going up and down.
Mm-hmm.
If the bigger number is under X, it's going horizontal.
Yes.
Well, then I
Correct.
redo my homework.
That is correct. Now, why is that important? And this is why you really need to really think about this for just a moment. Not every one of these formulas works the same, right? Well, in this problem set, they wanted X to be first every time, so it would be like a circle. Because a circle formula is a special ellipse. If I divided both sides by the radius squared, it'd have the same number under each one instead of two different numbers. Okay? And that would make it equal to 1 on a circle formula. Well, hyperbolas don't do that. Hyperbolas put the variable first that's most important. And because hyperbolas put the variable first that's most important, A is always first. But in ellipse, they don't do that because they want the x's to be first, so it'll be like circle, since circles are a similar type shape that's just perfect all the way around. So that's why you have to know which one's larger is where it goes. So now I take the b and square it and get 1 squared is 1. Do I really have to write a 1 into there? No, I could leave that off and it would be correct. Because everybody knows that to make something a fraction, you put it over 1. Now in our last problem, they gave us a graphic thought. That's even better, because when they give a graphic thought, all you got to do is count it up. Although this is not the best graph. So how far is it up to the top from the center? 8, because it's going by 2s. 2, 4, 6, 8. So A is equal to 8. How far is it from the center over to the co-vertices? 6. So B equals 6. Where is my center? So now that I've got all that information, I now know that x minus h will just be h squared. I know y minus k is going to be y squared. I'm going to square each one. So the bigger one goes under. Alright, so we're going to square A and get 64 and put it under y because it was up and down. And square B and get 36 and put it under the other one. And that one wouldn't have been any harder. Even if I'd have shifted it off a 0, 0, it would just have had parentheses on the top.
Yes.
Alright, so now let's look at how do you fix the formula. And I'll tell you what, I'm going to give you all a few minutes to try some of those at the bottom of that page before we do this. How about that? I'm going to stop the video, give you a moment to try at least a couple of those at the bottom of the page that says it's independent practice. See if you can make the formulas.
So where it says that they're endpoints, they're just the points.
They're either vertices or co-vertices. Now you'll have to figure out which they are because one of them will be longer maybe than the other way. But yeah, endpoints are just vertices and co-vertices. Okay, on the independent practice for the second section in the packet, number 4 should read the vertices are 5, 0 and 5, 12. The endpoints, positive, the endpoints are supposed to be 0, 6, and 10, 6 instead of 0, 6 for both of them.
But it's supposed to be a positive 6.
It's supposed to be a positive 6 on both of them. So I just got happy typing and just,
What about the 5?
they're all positive.
She's going to throw some negatives.
No, I just was not typing very well. Alright, so has everybody got the idea now? Is that the only one so far? It seems like it don't work? Alright, if you come across something else, let me know and I'll record it so that the others will know. Alright, so we're going to move on to the section where you have to do the completing the square. Because every problem set has something without completing the square. Yeah. He's not paying attention, is he? Alright, so it's a little bit more complicated than the circle ones. And the circle ones could have been more complicated. I didn't never put a number in front of the squares for circle. Because I thought if we did some simple ones with that and you got that under your belt, then when we came to ellipse and there was numbers in front, you could do circle ones the same way. I know this is an ellipse because the square terms have different numbers. But if they had the same number, I could just do it like ellipse to complete the square, and then it turns it into a circle problem. So because of that, I feel like that I made circle a little bit too easy because there wasn't numbers in front of the squares. It takes an extra step to take care of that thought. And after you get that kind of behind you, it's really simple. But it is a little bit, one extra step to deal with the fact that there's numbers in front. You still organize it the same way, though. You still put your X's, and then put a blank, and then put your Y terms, and put a blank. And then you move your constant to the other side. Now, you don't move more than one thing to the other side. This is like circle. Didn't we only move the constant? Okay, so that's going to make it positive 164, but I'm also going to put 2 blanks. Because I have 2 blanks on the left, so I have to put 2 blanks on the right. Now, here's where it differs from circle. Completing the square does not work if there's a number in front of the square. But what you'll notice is I could take 9 out of both of these, and that's what I do. Now, I can't take 9 out of the blank, right?
Right.
And then I do the same thing over here. I take the 25 out so that the y squared doesn't have anything on it, and that makes it 2y plus blank. Now, I do nothing to the other side, and don't even write anything down over there, because if you do, you'll mess up. No, you don't want to do that. Yeah, we want to leave the x's the way they are because we're getting ready to complete the square and fill in that blank. And so we don't want to take any x's out. You can only take the number out, just like with parabola, we took the number in front of the y or x out. On these, we take out what's in front of the squared, and we leave everything else alone. Because now, this problem has numbers we've looked at. What did I tell you about? When every time it's 4, it's because 4 divided by 2 is 2, and 2 squared is 4. But that's this blank. That's not that one. And the one at the top is the one that's on the other side. So now we've got to multiply this 9 times the blank because we didn't know 9 times what made that blank. But now that we have the blank filled in, 9 times 4 fills in a 36 up here because if I distributed this, I'd get that back for the 3 terms. So now I put 36 over here. We do the same thing with the second one. 2 divided by 2 squared is 1, right? I told you when it's 2, it's 1. So you just memorize that. They use it a lot. But I got to go back and do 25 times 1 to fill in the blank at the top is 25. And that puts a 25 on the other side. Now, I leave those numbers in front of that parentheses. They're not going anywhere right now. We're still doing the same 2 thoughts. Did I not fill in the blank? Well, the second step to completing the square is to make it a parentheses squared. So I factor the parentheses. X squared minus 4x plus 4 comes out to be x minus 2. Because the square root of each end is x and 2, and the sign in the middle is negative. Over here I have 25, and I've got to square my parentheses. So I factor the polynomial and get y plus 1. Then I add everything on the other side up so I can see what it's equal to, because it's not equal to 1, and that's a problem. It's got to be equal to 1. So how much? 225. All right. So I can see it kind of is like circle formula, except these two numbers are different, right? And when they're different, that means it's not a circle. So if it's not a circle, that means I need to divide everybody by 225 because I got to get it equal to 1 because the ellipse formulas are equal to 1. So we divide by 225. And this is a real simple step. It's not complicated at all. It's just something we got to do to get it equal to 1. And once we get it equal to 1, basically what you're going to do is say 9 over 225 reduces to what? And hopefully 9 goes into 225 evenly.
126.
Okay, well then we're just going to put 125 on the bottom. Because who needs a 1 on top, right? And then that means that 25 must go into that 9 times then.
It's 1 into 20. It's 1 over 25.
Oh, 1 over 25. I'm sorry, I misunderstood you. So if it's 1 over 25, that means 9 times 25 makes 225, right? So basically what you're doing is you're just dividing the top number into the bottom number so you can keep the number on the bottom. So 25 goes into 225, we'll make it 9. Or 1/9, right? But I don't write a 1, I just write the 9 on the bottom. So it's really the tops being divided into the bottom like reducing fractions. Alright, so now that we've got it all reduced down, we can go back over what we learned yesterday. So where is my center? 2, -1, alright? And which way is longer? Then A is 5 and B is 3. So now we're going to make a graph. And since our center is just a little off of it's not too far from the origin, and these numbers are 3 and 5, we probably could put it in the middle. So over 2 and down 1 for the center. And the x is longer, so we're going to count 5 out in each direction for x. 1, 2, 3, 4, 5. 2, 3, 4, 5. All right, so where are those 2 points now?
3, -1.
How about -3?
-3.
All right, -3, -1, and where? 7, 1. Okay. -1, 7, -1. All right, that makes sense because 2 plus 5 makes 7 and 2 minus 5 makes -2. Now let's do the B part. With the B part, we got to move up and down 3. So up 1, 2, 3, down 1, 2, 3. And those are my covertices, so we put CV next to them. Where are they located? 2, 2. All right, I'm going to erase these numbers I wrote over here in my way. 2, 2, and what? 2, -4. All right. And now we got to calculate up our distance for C so that we can find our foci. So C squared is equal to 25 minus 9. Now remember, there's no reason to go all the way back to these A's and B's and square them. They're already here squared. This is A squared minus B squared. That's the numbers that are underneath the problem. But you could say 5 squared minus 3 squared if you forget that. 16. I'm going to choke myself here. Turn around this way. And so that makes C... Ooh, that was a bad thought. No, it was a bad thought to spin around the other way. Because now the room's spinning. Okay, so now I got C is 4, which you're right, is a really good number. So 1, 2, 3, 4. 1, 2, 3, 4. And there is my graph of my... Hold on to the wall. ellipse with my foci on the x direction because the x is longer, right? And that just makes my foci one less than my vertices. So that should be -2, -1, and 6, -1. So it's just a little more complicated to get that first couple of steps done because there's a number in front of the x's and the y's, unlike the circle problems that we studied. So hopefully, maybe at some point, we might even could try one with circles like this because circles work just like this. The only difference is, if this had been a circle, I wouldn't have divided that 225 into both sides. I'd have left it over there so it could be the radius squared. That's the big difference between ellipse and circle. And we also don't do foci for circle because there would be 4 of them because it's the same in all directions. How would I know which one's longer? Right? So that's why we don't do them. All right, let's do another one. So you always start off with x's because x's are always first in all ellipse formulas. And bring your 39 to the other side and make it positive. Did I get all the signs right? Alright. Now what you'll notice is the x has a number in front of it, but the y doesn't. But I still need to take something out off of that x in order to be able to complete the square. B divided by 2 squared only works if there was a 1 in front of your squared term. So therefore, I take 4 out. I don't need to take out anything on the other one, so I don't even have to bring it down. I just bring down the part that I want to work on. Now, the middle is 4. What did I tell you it was when it was 4? 4, because what's 4 divided by 2 quantity squared is 4. But there's already a 4 out in front, so what's that filling this blank with? Correct. It makes it 16, because if you go back and redistribute this 4 through, you can fill in the blank above, which fills in the blank on the other side. The blank inside the parentheses does not fill in the blank on the other side. That's why it's important to distribute it back and go back to the top row. Now, I don't need to bring this one down to take anything out or anything, so I didn't write it down here, although I could have, but I don't need to. It's got a 1 already. What did I tell you it was when it's 6? 9. Because 6 divided by 2 is 3, and 3 squared is 9. So now we're going to go back and we're going to make our parentheses squared for this 4 that's outside, stays there. And what does the inside of my parentheses become? X plus 2, okay. Now over here with the y part, I go back up here and look at the original problem that I filled in that 9 on, and I say, what for that one if I factor it? Okay, at y minus 3. And then I add the other side up. This is 64. So now I realize this definitely is an ellipse because the number in front of the first parentheses and the number in front of the second parentheses don't match, which is why we're dividing by 64, because ellipses have to be equal to 1. Now the y term doesn't need anything done to it because there's nothing on top. But over here with the x's, I need to say 4 goes into 64 and get that bottom worked out, because you can't have a number on top in your final answer. It has to all be on the bottom. 16. Now, if that 4 doesn't go into that 64 evenly, we would say 64 divided by 4 and math bracket if it didn't go evenly. Does that make sense? It's always the bottom divided by the top, so it really isn't reducing fractions in some respects. It's more like somebody flipped multiplied and I'm flipping it. So that's why it always ends up everything's on the bottom, even if it don't divide evenly. So now, which one's A? X or Y? Alright, because Y is bigger. A is going to be equal to the square root of that, which is 8. And B is going to be equal to the square root of this, which is 4. So now that we've got that information, we can go over to our list and start working on it, and our center is -2, 3. Alright, so we gotta go 8 on Y up and down from 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. I don't know if that's a good place or not. Is that 5 from the bottom? Yep. Alright. I should move that. So if I go over -2 and up 3 and put my center, I've got to count 8 up and 8 down to be able to get my graph to have the vertical. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this one barely fits. If one thing about it, if it don't fit, you'd have to change your scale, and both directions would have to be changed. You don't want to make it where one's ones and the other one's twos. Now that's doable on other kinds of graphs, but on these graphs, both the x and the y-axis have to have the same scale. And then we're going to do 4 out in the other two directions to get the co-vertices. So 1, 2, 3, 4. 1, 2, 3, 4. Now, I learned a long time ago that counting those numbers off the graph is not the best way to do it. So let me explain to you a shortcut in case you like shortcuts. Which one was longer? By how much? So what is 3 minus 8? And what is 3 plus 8? And that's where those 2 points are. Do the same thing with the x's. X was 4, right? So take -2 and subtract 4 from -2. -6. And add 4 to -2. 2, 3. And that makes these points that I've got on my graph without having to count them off the graph. And since I'm dizzy, counting on this graph makes me dizzy. So now, let's do our c squared equals a squared minus b squared. So it's going to be 64 minus 16. What is 64 minus 16? 48 beats tree. 16 times 3 makes it 4 square roots of 3. Who gets it, x or y? Y. So it'll be -2, comma 3 plus or minus 4 square roots of 3. Instead of writing 2 separate ones, I just write one big point with the plus or minus in there, and that takes care of it. Because it's really -2, comma 3 plus 4 square roots of 3, and -2, comma 3 minus 4 square roots of 3. But that's kind of long, so we just write it as a plus or minus to save writing. Alright. How many more of these are there before we get to independent?
3 and 4.
3 and 4? 2 more? Okay. Alright, this time we have a number in front of both of them. We have a 9 and a 4. That definitely makes this addition between these squares an ellipse again. And I keep focusing on that because I could throw a circle one in, and you should be able to recognize it's not an ellipse, even though the math could be worked the same way. Alright. So, 9x squared plus 36x plus blank plus 4y squared minus 24y plus blank equals what? Alright. Alright, -36 plus blank plus blank. Alright, so we're going to take a 9 out. What's that going to make it? Alright, so what's going to go in my blank? I'm going to fix this one all the way out before I go to the second one. That makes it 4 again. If that blank's 4, what's the top blank? Alright, so that puts 36 on both sides. What does that do with that -36 already? Okay. Then if we take a 4 out, what will I have? And what I tell you was when it's a 6, 9, but then I got to fill in the blank up here, which is 36 also, because 9 times 4 is 36. So this adds up to 36, right? So now I need my parentheses squared. So this is what? X plus 2, y minus 3. Now, when you divide the problem by 36, if the two numbers in front of the two parentheses multiply to make that 36, all they do is switch places. Think about it. 9 goes in there 4 times, 4 goes in there 9 times. What 36s? Yeah, negative 36, 36 cancel. So x plus 2, quantity squared over 4, plus y minus 3, quantity squared over 9, equals 1. Who's longer this time? Y. So A is equal to 3, and B is equal to 2. Now, I'm not going to graph it. Let's see if we can do it without graphing it this time. As far as we can. But the graph is part of the answer, by the way. But I want to see if we can do it without it. What's my center? Negative 2, 3. That seems like that's what it was in the last one. Boy, I do like negative 2s and 3s. All right, y is more. So look at this y. It's already a 3. We got to add and subtract 3. So let's subtract 3. What's it going to be? And what is it going to be when I add 3? All right, so we add and subtract 3 from the y because A was 3. Now let's do the same thing with the original center and the B. We're going to change the 2. Subtract 2 from this. Negative 4, 3. Add 2 to negative 2. Do we need a graph to figure all that out? No. Then your foci is going to be c squared equals 9 minus, thank you. I couldn't turn my head to look for it. So it'll be square root of 5. Who gets it? Y. So negative 2 comma 3 plus or minus the square root of 5.
Where do you have to change the negative from the negative 2 from?
Yeah, I always put it on the center. And you just have to decide if it goes on X or Y based on which one's longer. Hold on just a minute. What did I miss putting on my last graph? I didn't put my foci. So let's go back and talk about that, and then I'll let y'all graph all that. All right. So I have my ellipse going here, but my problem is I didn't put my foci on here, and I'm supposed to put foci on here. Well, I got the square root of 48, which is almost 7, because the square root of 49 would be 7, right? So we're going to go up 7 and just hang down a little bit from it. How come I'm going up? 5, 6. Yes, because it's supposed to be below it. Just a hair below 7. And then do the same thing on this end, just a hair below 7, which is a little bit above that line. And there's your foci. So you just estimate it as a decimal and plot it on that line where your longest direction is from the center. Does that make sense? All right, I'm going to give you all a second to graph that last one and see if you can get your foci in there for that square root of 5. And I'm going to pause the video while y'all do that. All right, so now that we've graphed number 3 and y'all feel comfortable with it, I suggest that you complete the rest of this packet for homework. Don't forget we have a parabola quiz tomorrow, and your parabola quiz packet is going to be due tomorrow.